Hey guys, welcome back to day 8. Today we are going to talk about literal equations. So a literal equation is an equation where variables represent known values. Literal equations can use letters for both constants and variables. So to solve for a particular variable in a literal equation, you're going to rewrite the equation and you're going to isolate the variables. So what does that mean? All right, it means that we are going to be using the golden rule of algebra a lot today. And for the first time in math, we are going to be really not using numbers that much, okay? So, all right, I want to think about it first. So if we looked at this example, it says solve for the triangle if triangle plus circle minus star is equal to the pentagon, okay? Well, just like when we solved an equation, we need to isolate the variable. So our variable is the triangle. So to get the triangle by itself, we need to get rid of the other shapes that are on the left side, okay? So if we have a negative star, if we take a positive star, okay, the additive inverse property says they would cancel out. Boom. Well, the golden rule of algebra says whatever we do to one side, we have to do to the other. So we're going to add a star. Okay, so that means we're left with triangle plus circle equals pentagon, let's give this a try, plus star. Okay, that was our first step. All right, now our second step is to, again, we're isolating the triangle, so we need to get rid of the other term. In this case, we have a plus a circle. If we subtract a circle, we would make that go to 0, and then we would subtract a circle on that side just to keep the golden rule of algebra. Okay, whatever we do to one side, we have to do to the other. So at this point, our variable is isolated, meaning our triangle is equal to the pentagon, okay, plus the star minus the circle, and we're done. Okay, so see how we did the same thing with symbols that we did with numbers, okay? Now, let's look at the second example we have here. We're solving for the circle, okay? This time we have star plus circle divided by triangle equals pentagon. Okay, our first step is going to be to get rid of that triangle. So when you're dividing, think of the inverse of division, it's actually multiplication. All right, so if I multiplied triangle times star plus circle divided by triangle, what happens here is the triangles cancel out because really triangle divided by triangle is just 1. All right, so that's how it's the multiplicative inverse property. Now, whatever we did to one side of the equation, we had to do to the other. Okay, so then the second step, we're actually left with the star plus the circle, it's a sad star, plus the circle equals the pentagon plus the triangle. Okay, now we're solving for the circle, so we need to get rid of this term of the star. So if we have a positive star, the opposite is a negative star, so we're going to take a minus star. And whatever we do to one side, we do to the other. Okay, so we're left with the circle is equal to the pentagon plus the triangle minus the star. Okay, so I agree that's kind of weird working with shapes. All right, we won't be doing shapes as much, but let's look at some formulas because that's what literal equations are used for, are formulas. So if you look at number 1, it says A equals, that's a lowercase l w. Okay, that's the formula for the area of a rectangle. Area equals length times the width. Now, if I wanted to solve for the length, all I'd have to do is, in this case, we have length times the width, the inverse of multiplication. Remember, when the variables are close together, you're just multiplying. Well, the opposite of multiplication is division. So if we divide by w, w divided by w is just 1, so they cancel out. Whatever we do to one side, we have to do to the other. So we're left with a divided by w equals l. Or I like to write my variable on the left, so I just switch the order. The length is equal to a divided by w. Okay, it's going to be really important that your variables, they're case sensitive, meaning if it's uppercase, like in this case, our a is uppercase and our w is lowercase, okay? Make sure you pay close attention to that because sometimes we'll get an example which it will have both an uppercase a and a lowercase a, and so you want to make sure that they're two different variables. All right, looking at number 2, we're solving for t, okay? So t, we want it to get by itself. So in order for t to be isolated, we're going to divide both sides by r, okay? Because remember, r divided by r is 1. So d divided by r is equal to t, or again, we write it as t is equal to d divided by r. So we just solved for t. And this is important that you make sure at the end when you get your answer that you actually solve for the right variable, because a lot of times kids actually accidentally might solve for r. Okay, so just be careful at the end that you solve for the right variable, because you can't really do a check step with this. Okay, all right, let's look at number 3. Now we're solving for r, so we can do this in one step, because here it's c equals 2 pi r. This is actually circumference equals twice the 2 times pi times the radius. Okay, so this is a formula for circles. So we're going to actually, to get the r by itself in one step, all we have to do is divide both sides by 2 pi, because 2 pi divided by 2 pi is 1. So we're left with c divided by 2 pi equals r, or again, I like to write it as r is equal to c divided by 2 pi. And that's your answer. All right, number 4, we're solving for p. So I is equal to, that's a capital I, p times r times t. So we can, in one step, divide both sides by rt. All right, so this would become I divided by rt is equal to p, or again, p is equal to I divided by rt. All right, number 5, we're solving for h. Okay, when you have a fraction, okay, in this case we want to get h by itself, so we want to get rid of the fraction. In order to take 1/2 and make it go to 1, we're actually going to multiply by the reciprocal, which is 2 over 1. So that's how we get it to be 1. We multiply both sides by 2. Okay, so I'm going to say this is 2a. We're going to multiply by 2, and this side by 2. Since 1/2 times 2 is 1, we're left with just the BH. Okay, that's our first step. Now to get h by itself, all we have to do is divide by b. Okay, so 2a divided by b equals h, or we can write it as h is equal to 2a divided by b. And that's our answer. All right, number 6, we want to solve for m. In one step, we can just divide by c squared. Okay, because again, if the variables are next to each other, you're just multiplying. So c squared divided by c squared is 1. So e divided by c squared is equal to m, or we can write it as m is equal to e divided by c squared. Okay, all right. I'm going to give you another example here because I want to show you the difference. Okay, watch what would happen here. Let's do this one in red. If we solved, okay, for c instead. Okay, so if I had e is equal to mc squared. All right, so the first step is pretty obvious. We would just divide by m. Okay, so we're left with e divided by m is equal to c squared. Now this is important. We're not solving for c squared. We're actually solving for c. Okay, so keep in mind that the inverse of squaring a variable is the square root. So if I took the square root of c squared, I would actually get c. Okay, so that's how we're going to get c by itself. We're going to take the square root of c squared, but the golden rule of algebra says whatever I do to one side, I have to do to the other. Okay, so that would let me end up with the square root of e divided by m is equal to c. Okay, or again, c is equal to the square root of e divided by m. Notice the square root is over the entire term. Okay, all right, so that was just a little side. I wanted you to see the difference between the two. In the first example, we're solving for m, so we didn't have to worry about taking the square root. But if we actually solve for c, that's when we would have to take the square root. Okay, all right, let's look at number 7. This is the perimeter is 2 times the length plus 2 times the width. So again, don't get confused by that. It looks kind of like a 21. Be careful with that. It's actually a lowercase l. I prefer to make the variable kind of cursive-y so it looks different. All right, so if we're solving for L, all right, in this example, we have 2 terms, all right? So 2L is a term, so we've got 2L is one term, and then we have 2W. Now we're solving for L, so the first thing we want to do is get rid of any other terms that we have on that side of the equation, and we do that by either adding or subtracting. So in this case, we have plus 2W. We're actually going to subtract 2W. That's going to be our first step. And of course, whatever we do to one side, we have to do to the other. So P minus 2W is equal to 2L. Okay, now to get L by itself, all we have to do is divide both sides by 2. Okay, so P minus 2W divided by 2 is equal to L. All right, so that can be your answer, or if you want to take it a little bit further and you can understand this, we're going to split it apart and we're going to take each term, P divided by 2 minus 2W divided by 2 equals L. Okay, and when I look at that, I realize, oh, I can simplify that even further because P divided by 2 stays the same, but 2 divided by 2 is 1, so these would cancel out. So P divided by 2 minus W equals L. All right, so it's a little more advanced way of showing the same answer. All right, number 8, we are solving for M. So again, I've got another term here. I have that B, so I'm going to subtract my B first. Okay, Y minus B is equal to MX. And then I'm going to solve for M by dividing both sides by X. M is equal to Y minus B divided by X. And there's my answer. All right, number 9. We're solving for x. Okay, so now we're dividing. X plus n divided by p equals m. The inverse operation of division is multiplication, meaning if I multiply that by p, p divided by p is just 1. So that'll make that cancel out. So whatever I do to one side, I have to do to the other. So p times m is equal to x plus n. Now to get x by itself, I simply subtract n. Okay, so PM minus n equals x, or I can write it as x is equal to PM minus n. Okay, and remember, multiplication is commutative, so that's the same answer as x is equal to MP minus n. All right, so you might have different variations of it. All right. Number 10, if we want to solve for x. Now notice we're dividing by x. We can't just multiply, we can't just multiply both sides by, or divide by k to get it alone. We have to do a little kind of intermediate. So to get rid of the k divided by x in the fraction form, we're going to actually start out by multiplying both sides by x. Okay, so then we're left with xy is equal to k. Now it's easy to get x by itself. All we have to do is divide by y. All right, so x is equal to k divided by y. Okay, all right, number 11, if we solve for a. Okay, in a problem like this, what I don't want you to do is distribute and make it more complicated. We are not distributing here. We're going to start out and we're actually going to just divide both sides by x. Okay, our whole goal is to get a by itself. So when we divide by x, we have a plus b equals 10 divided by x. Now all I have to do is subtract my b. So we end up with a is equal to 10 divided by x minus b. Okay. All right. Number 12. All right. We've got our fraction again. So we can start out and multiply both sides by 2 to get rid of that fraction, because remember, we don't want to distribute it. So we're going to multiply both sides by 2. When we do that, we get 2 capital A is equal to h times a plus b. Notice here's an example where we have an uppercase a and a lowercase a. They're totally different variables. All right, we're trying to get lowercase a by itself. All right, so now we want to divide by h. Okay, we're left with 2a divided by h equals a plus b. Now to get lowercase a by itself, we just need to subtract our b. Okay, so we end up with 2a divided by h is minus b is equal to a. Or I can write it as a is equal to 2a divided by h minus b. Okay, and there's our answer. All right, 13. All right, 13, we want to get b by itself, so we can start off and just subtract a. So b plus c is equal to 180 minus a. Okay, and then we can just, to get b by itself, subtract our c. So b is equal to 180 minus a minus c. And that would be our answer. Okay, or don't worry, you could have it b is equal to 180 minus c minus a. Okay, they would be equivalent. Okay, just make sure the sign that's in front is what goes along with the variable. All right, now the last one, number 14. Okay, we're going to get C by itself. The first thing we want to do is subtract the 32. Okay, so this is F minus 32 is equal to 9/5 C. Okay, now to get C by itself, we're actually going to multiply by the reciprocal of 9/5. 9/5, remember, to get the reciprocal, you flip the numerator and denominator. So if we multiplied by 5/9, we would end up with 45 divided by 45, which is 1. Okay, so that's how we end up getting rid of the 9/5. We multiply both sides by 5/9. But because I'm multiplying the left side by 5/9, I need to be careful and put it in parentheses. Okay, and that's going to be times 5/9. All right, so 5/9 times F minus 32 is equal to C. Okay, or we can rewrite it. You can actually distribute it at this point if you want. Okay, or let's just write it like this. C is equal to 5/9 times F minus 32. Or if you distributed it, this would be C is equal to 5/9 F, okay, minus 169. Okay, all I did was distribute that fraction. Okay, so either answer would be fine right here. Okay, all right, so I know that was quick. It's not intended for you to just learn from this lesson. This is to supplement the time that we had in class, and maybe you can fast forward and get to some problems that you were having issues with. And I hope that this helped you out a bit. Okay, bye-bye.